Hello everyone, I am Ritika Sharma, Assistant Professor, Computer Science and Engineering Department, Maharaja Ghazi University, HP. In the last lecture, we have discussed about the basic introduction to data structure and array data structure. My today's topic of discussion is stack data structure. First of all, I would like to discuss about the data structure. What is data structure? Data structure is generally a mathematical model which is used to store and organize the data efficiently. It is further divided into two main categories: linear data structure and non-linear data structure. Linear data structure in which data is arranged in continuous memory locations. For example, arrays, stack, queues, and linked list. Similarly, we have non-linear data structure in which data is not organized in linear manner. Means, for example, trees, graphs, and files. In trees, data is stored in hierarchical form. Similarly, in graph, data is stored in hierarchical form, and in files, data is stored in the directory form. So our today's topic of discussion is stack data structure, which is known as linear data structure. So what is linear data structure? In linear data structure, data is arranged in linear sequence. For example, arrays. In arrays, we can insert the elements into the continuous memory location, and element which is need to be inserted are homogeneous in nature. In linear data structure, we can access the items in a single run. We can place the items into the continuous memory locations. We can arrange the item together. So what is stack? Stack is generally based on the principle of LIFO. It is a in it also the items are stored in continuous memory locations. In stack, as we know, it works on the principle of LIFO. It means last thing we added is the first element that gets pulled off. And stack is also a sequence of items that are accessible at only one end of the sequence. We can use the top variable to insert or delete the element from the stack. We can use only one end to insert or delete the element from the stack. This is the real life example of stack. We have in the left hand side, we have a stack of books, and in the right hand side, we have a stack of dishes. Next, stack as an abstract data type. As we know, stack is used to store the finite sequence of elements, and it is known as abstract data type. It has following operations: create empty stack, push, top, pop, is full, is empty. Create empty stack means we have to create an empty stack. Next is, if we have an empty stack, we need to insert the element into the stack. Then we have push operation. Push is generally used to insert the items into the stack by using top variable, top of S. As we know, if stack is not empty, then we can access the element from the stack using top variable. Pop. Pop is used to delete the element from the stack. As stack is not empty, we can delete the element from the stack. Is full. Is full is an operation which is used to find whether our stack is full or not. It will return true or positive value if stack is full, or false or negative value if stack is empty. Is empty is also another operation, and it is opposite to is full. It is used to determine that whether our stack is empty or not. It will return true if stack is empty, or it will return false if stack is not empty. Different type of operations we can perform are on stack. We have generally two type of operation: push and pop. Push is used to insert the element into the stack, and pop is used to delete the element from the stack. Both the operation can perform with the help of top variable, and we can insert or delete the element from one end. That is, stack is open at the one end. Uh, Another, we have one another operations that is called peek. It is also used to access the topmost element from the stack. For example, we have a stack in which we have three elements: A, B, and C. Now this is at, A is at location 1, B is at location 2, and C is at location 3. Now top is at location 3 at element C. If we want to perform peak operation, then it will return the element C without deleting the element C. Instead, if we want to access the element, we can use the pop element, because pop will delete the element and print the element. But if we want to print the topmost element, then we can use the peak operation, because peak will return the topmost element of the stack. Now, how push and pop works? For example, we have push D. Now top is at location 3, that is at element C. First, it will increment the top by 1, that is top is equal to top plus 1, and insert the element D onto the stack. Next, we have E. Again, we have to perform push operation. Now, top is at location 4 at element D. Again, we will increment the top by 1, that is top is equal to top plus 1. It will increment the top by 1, that is top is now at location 5, and now we will insert the element E. For deleting the element, we don't want to mention the element. We have to write simple pop. Now it will delete the topmost element from the stack. It will print A, B, and C as D is deleted from the stack. Again, we have another example of push and pop operations. Here we can perform 6 push operations and 4 pop operations. First, we will insert uh, one is already present into the stack. We will insert 2, 3, 4, 5 sequence 5 and 6 one by one onto the stack, and we will perform 4 pop operations onto the stack. First, it will delete the element 5, then it will delete the element 4, it will delete the element 3, and it will delete the element 2. At the end, we have only one element present onto the stack, that is 1. Now question arises here, what will be the pop sequence? Then the pop sequence will be 5, 4, 3, 2, because pop will delete one by one element from the stack. Now we can perform push and pop operations by using algorithms. Now, for the insertion, we use push operation, and for deletion, we use pop operations. So algorithm for the insertion of element into the stack is, first we will create a function insertion of stack by using top variable, insertion of item, and we have another max variable. Max will define the size of the stack. As we know, stack is of finite size, then max is used to define the size of the stack. For example, we will consider the size of the stack is 5, the max is 5. Now in step 2, first we need to check, is there any space present over the stack or not? The second step will be, if top is equal to max minus 1, mean top is at max or top is present at the end of the stack, then it will print stack overflow, means there is no more space to insert more element onto the stack. If this condition is fail, it will exit. This condition is true, it will exit from the algorithm. If this condition is fail, then it will go to the step number 3. It will read the item which we will insert onto the stack. After that, it will increment the top by 1 and insert the item onto the top of the stack and exit. For example, we have 3 elements A, B, C already present over our stack, and we have insert our element D onto the stack. First, we will read the item D and check whether there is space available onto the stack or not. If there is space, we will read the item D and increment the top by 1. Top is at location 3 at at item C, we will increment the top by 1 and insert the item D onto the stack. So according to this, we will perform our insertion algorithm. First, we will check the space, then read the item, increment the top and insert the item. These are the 4 main steps while we performing insertion into the stack. Things to consider. First one is stack underflow. Stack underflow means when we want to remove or delete the item from the stack, but there is no more item present into the stack, and the top is at location -1, means top is set at location -1 other than 0 to any other location. So it means there is no element which when nothing is actually there is to remove, means there is no item present onto the stack. Similarly, second thing to consider is stack overflow. When we try to insert one or more item onto our stack, but there is no more space available, then there is stack overflow. For example, we have a stack A in which items are A, B, C, D, E. All the memory locations are already full. If we want to insert the item F, then it will print overflow because there is no more space available on our stack, and top is set at location max. Next algorithm is for algorithm of deletion in stack. For example, deletion algorithm. First, we will consider a function deletion of stack. We will delete the element from the top and item that is we will delete. First, we will check the underflow condition. Is stack empty or not? If the stack is empty, then it will print underflow. That is there is no more element to delete, and it will exit from the algo. If not, it will delete the top element from the stack, or it will set top element of the stack to null, and after that it will decrement the top by 1 and exit from the algorithm. For example, stack initially it has 4 elements, 5, 10, 12 and 15. Top is at location 4 at element 15. When we perform pop, it will delete the element 15, free the memory location and decrement the top by 1, and top is now at location 3 at element 12. Similarly, if we perform pop 1 again and again, it will empty the stack and print all the popped values. Next is the algorithm used to display the stack elements. Here we will perform stack display function onto the by using top variable. I is used for looping from topmost element to 0th element of the stack and stack of I. Again, we have to check is there element present onto the stack or not. If top is equal to -1, it means stack underflow. There is no more element to delete from the stack or to access from the stack. If the condition failed, we will move to the step 3. Now here we will set for I is equal to at top and to 0, and we will decrement the I 1 by 1 and access the elements 1 by 1 and print the element of the stack. Next is we applications of stack. Generally, we have different areas where we can perform stack operations to solve the problems in simple and efficient manner. Generally, we have 5 types of applications. First one is reversing a list. Second one is parenthesis checker. Third one is conversion of infix expression to postfix and prefix. Here we will firstly study the infix, postfix and prefix notations. Fourth type of application is recursion, and fifth is Tower of Hanoi. So considering the first application, that is reversing string. When we want to reverse a string, then stack is the data structure which is very helpful. For example, if we have a string stack, stack, if we want to reverse it, means we want to print K, C, A, T, S, then we will use stack. How it will work? Once all the character of the strings are pushed onto the stack, they are popped one by one. Since the character last pushed in comes out first, subsequent pop operation result in the reversal of the string. Considering the example of string reverse, here we can start inserting the element from left to right by using push, and we will get the reverse of the string. For example, first we will insert R, E, V, E, R, S, E. Now top is at E. Now we will start popping the element one by one, and it will popping the element one by one, and it will reverse the string. It will print E, S, R, E, V, E, R. Means while we performing reverse of a string, then we can simply use the stack. Second type of application is checking the validity of an expression containing nested parentheses. When we have nested parentheses, nested brackets, or nested symbols, then we can simply use these applications. This application is also used to check the validity of expressions. So stacks are also used to check whether a given arithmetic expression containing nested parentheses is properly parenthesized or not. It is also used to check the validity of an expression. For example, we have a set of opening and closing parentheses. Then it is a valid input. When we have a opening parenthesis and closing parenthesis, but a single opening parenthesis, a bracket, but there is no closing bracket, there is no pair of this opening bracket, then this is invalid input. Similarly, we have a pair of opening bracket and closing bracket, opening parenthesis, closing parenthesis, opening square bracket, closing square bracket, but this is a valid input. But we have opening bracket, closing bracket, okay, opening square bracket, closing square bracket, again opening open bracket, closing bracket, but for this bracket there is no pair of closing bracket, so this is a invalid input. Similarly, we can check the validity of nested parentheses and nested square brackets to check the validity of expressions. Third type of expression is to evaluate arithmetic expressions. Arithmetic expressions are in which operands are the basic objects on which operations are performed. We have generally three types of notations: infix, postfix, and prefix notations. Common expressions are of like 2 plus 3, a minus b, p star 2. Here 2 and 3 are the operands and plus is operator. Capital A and B is the operand and minus is the operator. So operands are the basic object on which operations are performed. So first one is infix notation. Infix notation are these type of notation in which operator is placed in between the operands. For example, we have a question 4 plus 6 star 2. Here plus is placed between 4 and 6 and star is placed between 6 and 2. When we want to solve this expression, we can clear the ambiguity by knowing the order of precedence. Here parentheses have the highest precedence, after that exponent, after that division, multiplication, addition, and subtraction. For solving this equation, we need to know the order of precedence. Here 4 plus 6 star 2 is the infix notation, infix expression. We want to solve this expression by using the order of precedence. So multiplication has the highest order of precedence when as compared to plus. So first we will solve 6 star 2. The answer is 12. Then after that we will solve plus 12 plus 4 is 16. The answer will be 16. In infix notation, the operators are placed in between the operands. Next, we have prefix notation. It is also known as Polish notation. Here, operator is placed before the operands, means we can write the operator before the operands. For example, we have an infix expression 2 plus 3. In prefix, it is written as plus 2, 3. Operator plus is written before the operand 2, 3. P minus Q. Minus is placed before the P and Q. So this is Polish notation, prefix notation. Similarly, we have postfix notation, reverse Polish notation. Here, the operator is placed after the operands. For example, we have an infix operation, operator expression 2 plus 3. According to the postfix, it is written as 2, 3 plus. Plus operator is placed after the operands. P minus Q, it is written as PQ minus. Minus is placed after the PQ. As we know, infix operator is very much understandable to human. But when we're talking about the computer machines, the postfix and prefix notations are good for machines. Now, conversion of infix to postfix expression. Here, again, we need to understand the order of precedence. First, brackets or parentheses, then exponential, then multiplication or division, and after that, addition or subtraction. The operators having same priority are evaluated from left to right. For example, A plus B plus C. Here we have two operators plus and having same priority. Then we will solve it from left to right. First we will solve A plus B, then we will solve plus C. Evaluation of infix to postfix expression. In postfix, operator is placed after the operands. Suppose an expression. Here we have an expression A star B plus C star D minus E. First, we need to add the parenthesis or bracket. Parenthesis started, A star B is in one bracket plus C star D is in one. Parenthesis closed minus E. As we want to change it into postfix, first we will solve the parentheses. That is AB star plus as it is CD star minus E as it is. Now again after that we will solve the parentheses. Here plus is in between the AB star and CD star. We will solve the plus. The expression will become AB star CD star plus. Now we will solve minus E. Again, it is postfix. Minus is placed after the E. So expression is AB star CD star plus E minus. So this is the final form, final postfix expression. AB star CD star plus E minus. If we place A is equal to 2, B is equal to 3, C is equal to 5, D is equal to 15, E is equal to 9, then what will be the result? We will solve each and every operator accordingly. First, 2, 3 star. We will multiply. As we know, the star is for used for multiplication. We will multiply 2 and 3. The answer is 6. After that, the expression is 6, 5, 4 star plus 9 minus. Now we will solve 5, 4 star. The answer is 6, 20 plus as it is 9 minus as it is. Now we will solve plus. That is 20 plus 6. That is 26, 9 minus. Now we will solve minus 20 minus 9. The answer is 17. When we want to convert the answer into a single form, then we can use the postfix expression. Evaluation of infix to prefix. Here, according to the prefix, operator is placed before the operands. Now, the same expression 2 star 3 plus 5 star 4 minus 9 can be written as, first we need to add parentheses or brackets. So we added parenthesis started, bracket started, 2 star 3, bracket close, plus bracket started, 5 star 4, bracket close, parenthesis close, minus 9. First, we will solve the inner brackets. That is star 2 3 plus star 5 4 minus 9. Now we will solve the parenthesis. That is plus. Plus is placed between these two. So plus is written before the operands. So plus star 2 3 and star 5 4 minus 9. Now minus is placed before the operands. Minus plus star 2 3 star 5 4 comma and 9. So final result will be minus plus star 2 3 star 5 4 and 9. So this is the final prefix expression where every operator is placed before the operands. When we want to solve it using prefix expression by using stack, then it is we have to scan from right to left. First, we will add 9 onto the stack, after that 4, after that 5. As after 5, we will have star operator. As we have star operator, we will multiply the first two operands. It is 5 into 4, 20, and 20 is inserted back onto the stack. After that, we will insert 3, we will insert 2. Again, we got star operator, then we will multiply 2 and 3, that is 6. The 6 is inserted onto the stack. After that, we have plus operator. So we will add 6 and 20. That is, the answer is 26. After that, we have minus operator. We will minus 26 minus 9. The answer is 17. By using stack, we can perform this. These are some practice questions. You can perform all these questions and solve accordingly. The answer of first question is A, B star, C, D slash plus. Second question, A, B, C star, D, E, F exponential divide G star minus H star plus 562 plus star 124 divide minus star minus A slash B, C minus star D, E, F. So solve these questions and match your results. So here is again example of infix to postfix conversion. Here we can assume the solved expression A, B or C. For example, we have an expression 2 plus 4 minus 1 star 3. First, we need to add parentheses. After that, we need to solve the brackets first. So bracket is 4 minus 1. As we need to convert into postfix expression, we will add minus after the operands. So it is 2 plus 4 1 minus star 3. Now we will consider 4 1 minus A. We will place A in front of 4 1 minus. Now we will solve the star operator. That is, A star 3 will become A3 star. We will place B in place of A3 star. So it is written as B plus 2 plus B star. So we have last operator, that is plus, so it is written as 2B plus. Now we will place the value of B, that is A3 star. We will place the value of A, that is 413 star. So this is the final result, final postfix expression. Now we have conversion of an infix expression into a postfix expression using stack. While we performing the conversion, we will have some order of precedence. The highest order of precedence is of exponential. After that, divide, multiply, and modulus operator. All these three operators have the same precedence. After that, the lowest priority operator will be plus and minus. These two operators have the same precedence. Next is algorithm to convert an infix notation to postfix notation using stack. First is we need to add parentheses to the infix expression. Second step is push bracket onto the stack. Third is repeat until each character in the infix notation is scanned. If a opening bracket is encountered, push it onto the stack. And if an operator is encountered, whether it is digit or character, add it to the postfix expression. Next, if a closing bracket is encountered, then repeatedly pop from the stack and add it to the postfix expression until a opening bracket is encountered. We will discard the opening or closing bracket and remove the opening bracket from the stack. We will not add it to the postfix expression. If an operator is encountered, this is very important step. If an operator is encountered, then repeatedly pop from the stack and add each operator popped from the stack to the postfix expression which has same precedence or higher precedence. Push the operator to the stack. Last step is repeatedly pop from the stack and add it to the postfix expression until the stack is empty. The last step is exit from the algorithm. So considering the example A star B plus C, it will become A B star C plus into the postfix expression. Firstly, we need to add the parenthesis to the expression, that is bracket start A star B plus C. The stack conversion is, first we need to scan the character, infix character, stack and post stack. First we have parenthesis. We need to add it to the stack. After that we have A operand. We need to add it to the postfix expression. After that we have operator. It is added onto the stack. Again we have B operand. It is added into the postfix expression. We have plus operator. Up here we have already an operator which is present into the stack, that is star. Star has higher precedence than plus operator. Then we will pop star from the stack, added it to the postfix expression and add the plus operator onto the stack. Next we have C operand. We will add it onto the stack. Last we have closing bracket. We will repeatedly pop from the stack. We will pop plus operator from the stack and discard the closing bracket. When note down, when the plus is read, plus operator is scanned, it has low precedence than the star operator. So we will pop the star from the stack. So this is all about the conversion of infix to postfix expression using stack. That's all about the stack operator. You can also solve this question. The answer is 4. Thank you. If you have any query, you can ask in the comment section. Thank you so much.